All right, this is the review for your Chapter 1 test that will be tomorrow. Thursday. Today we're going to be going through a bunch of different practice problems, keeping in mind you can do one of two things. You can already try the Google Doc by yourself, go through, fill it out, or do it on a piece of paper, and try to solve each of these equations by yourself, and then watch the video and check all of your work to make sure that you got it right, and if not, what mistake did you make so that you can fix it before your test. Or if you want, you can go step by step. So for each of these types of problems, there's about at least three or four in each section. So if you want to watch me do the first one and then try the other three, pause the video and try the other three yourself, and then start the video again to check it. However you want to do this is kind of your review. At the end, I will ask you to submit a picture of either your completed Google Docs, so if you do type it out on Google Docs, or if you do it on paper, I'll ask you to submit a picture of your work later. So either way, you will want to complete this assignment. Again, it's not based on whether you get all of them right or wrong, but whether you've actually done the work for all of them. So just keep that in mind. So here we go. So first and foremost, we did do solving equations at the beginning of this chapter, but you just took a checkpoint quiz over that within the last couple days. So there will be no solving equations on this assessment. It's going to cover order of operations / evaluating functions, patterns and their growth rates, what a function is, and the inputs and outputs on a graph, domain and range, and then graphing points. So that's everything that's going to be covered. We're going to do practice problems from all of those, okay? All right, here we go. So first things first, we have determine the corresponding inputs and outputs for the following functions. Show all your work to receive full credit. Keep in mind, whenever it says this on a test, that means you want to show all your work. Not just put the answer as x equals 2 or f of x equals 7. If you just write an answer, you won't get full credit, just so you know. So I have a couple problems here. Let me scroll up a little actually. So I have 4 problems here, all with that same instructions, finding the inputs or outputs. So remember, outputs means we're looking for the answer that's coming out the problem. So we're looking for our f of x. So right here where it says find f of x, that's an output. Whenever we're given the f of x and we're looking for the actual x in the problem, so here we're given the f of x, we're looking for the actual x in the problem, that's when it's the input. That's when you have to work backwards. So right here, they say take a -9 and plug it in. So we're going to take a -9 and we are going to plug it into this equation, which means we are going to square it and then add 3. So in our heads, -9 times -9 is going to be a positive 81. And then an 81 plus 3 is going to be an 84. So that is our solution for this first problem, is x, or f of x, equals 84. Again, when you're doing this on the test, I'm just going to have a blank for just the answer. So you're plugging in just 84. You don't have to worry about writing f of x or any of that. Now notice on this one, it's saying what number can I plug into this and get a -1? Well, I can sit here and try to plug in numbers. If I plug in a 4 times 3 is 12. 12 minus 7 does not give me a -1. So I can try to plug in numbers, or I can set up an equation. If I know that my equation is 3x minus 7, and normally I take this number and I plug it in right here where the x is, and then I make it equal to my answer, the answer I'm trying to get. Well, the answer I'm trying to get here is a -1. So I am going to have a little bit of solving equations because I can work through this by solving the equation. That means I can add 7 to both sides. So when I add 7 to both sides over here, I'm going to end up with 3x. And over here, I'm going to end up with a 6. And then I can divide by 3, and get x equals 2. So that should have been the number that goes up here is a 2. Let me try to make this a little bit smaller, so hopefully it's easier to write. Okay, that's what it's going to look like if they give you a function machine. If they don't give you a function machine, you're still doing the same thing. They're just writing out in words, right? Find f of 3. Okay, well that means x equals 3. So anytime I see an x, I'm going to plug in a 3. Minus 3 plus 5. So notice there were 2 x's here. So I plugged in the 3 for both x's, both here and here. Now I'm just going to solve. 3 times 3 is 9. Minus 3 is 6. Plus 5 is an 11. So my answer here is going to be an 11. And then same thing with this one. It says find x. So again, we're trying to find that x. So we're trying to find what we plug in when f of x equals 10. So here I have my equation, 3x minus 2. And then we know that that equals 10. So then I can solve it by adding 2 to both sides, plus 2. So then over here, I'm going to write it over here so I have space. I have a 3x on this side, and on this side I have 10 plus 2, which is 12. And then my last and final step would be to divide by 3 and get x equals 4. So that was our number, our input that we plugged in. That is the first section of this test. We're going to keep going into the second section, which is going to be our patterns. So we are given a pattern, and we have to answer a couple different questions. They're going to make you sketch one of them. Sometimes they make you sketch the next figure. Sometimes they make you sketch the figure before. In this case, we're going to be sketching figure 1. So we need to look at these 3 things and figure out what is our pattern. Okay, well in all of these 3, we have this like upside down L shape. They're all the same. All of those 3 are the same. The only thing that's changing differently is here they have 2 on the outside. Here it added 2 more on the outside. Here it added 2 more on the outside. So every single time they draw a figure, it looks like they're adding 2 boxes onto the outside. But this L shape is staying the same. Which means if I were to sketch figure 1, it would still have that L shape with the 3 boxes up at the top. The 1, 2, 3. And then the 3 boxes going down. It's still going to have this L shape, right? But notice here we had 6 boxes, and then we had 4 boxes, and then we have 2 boxes. So over here it's going down by 2, or getting higher by 2, which means over here we're not going to have any boxes on this side. So this should be what figure 1 looks like. Just that L shape with the 3 boxes and then the 3 across and 3 down. So that's our shape 1. So now it says, what is our growth rate? Again, how much is it growing each time? Well, again, from here to here, it's only adding 2. From here to here, it's only adding 2 more. We can also count, right? There's 1, 2, 3, 4, 5 boxes for figure 1. So this is going to go into the making the table part. So let's do that at the same time as trying to figure out our growth rate here, x and y. So x stands for the figure. So this is figure 1, figure 2, figure 3, figure 4, and figure 5. And then this is going to be how many boxes are in each figure. So again here, 1, 2, 3, 4, 5. Figure 1 has 5 boxes. Figure 2 has 1, 2, 3, 4, 5, 6, 7 boxes. 5, 6, 7, 8, 9 boxes. 5, 6, 7, 8, 9, 10, 11 boxes. So notice, what is it going up by each time? Well, 2. That means our growth rate is 2. And then, of course, we can keep going. If I add 2 to this, I'm going to get 13. And then the next question, so that answers all 3 of these first questions. My sketch is right here. The growth rate is 2. I have my table from 1 to 5. Now, how many is going to be in figure 7? Well, I can just keep adding 2. 6 is going to have 15, which means 7 is going to have 17 boxes, or 17 tiles. So those are the type of questions that you're going to be answering with the patterns. Nothing too difficult, but we are going to be using the patterns in the next chapter, so we do want to make sure that we understand those. Okay? We'll move on to our next section, and then I might have to do a second video for the last one. So our next section, before we get into domain and range, is just what is and what isn't a function. So first and foremost, you want to write your definition here. I'm not going to type out the definition, but I will state it. Your definition that should be here should be something to the effect of a function is a relationship that for every input has at most one output. Okay, so again, remember, for every x value, there should be only one y value that goes with that. There cannot be more than one y value or more than one output. Draw a picture of something that looks like a function and something that doesn't look like a function. So again, keep in mind, a function cannot have any repeating parts if you draw a straight line, right? So I can draw something that looks like this. That would be a function, right? Because if I draw a straight line, it's only going to hit it at one spot. So that would be something that is a function without the straight lines. Something that is not a function, again, has to be something that overlaps to where if I draw a straight line, it's going to hit it in 2 spots. So maybe something that looks like this. It's not a function because it's going to hit it in 2 spots. Something like this, not a function because it's going to hit it in 2 spots, okay? So not with those vertical lines, because those vertical lines are not part of the function we're looking at, but the image itself. And again, just making sure that you understand the difference between what is and is not a function. So now we can look down here and say, okay, which one of these are and which one of these aren't? Well, again, each of these x values should only match up with one y. So 3 has to go with 2. So we look and see, are there any other 3s? No. Okay. 4. 4 has to go with a 1. Are there any other 4s? Yeah, there's another 4 here and another 4 here. However, both of those are still 1s, which means yes, this is a function. And then same thing with 5. 5 should only go with 6. Okay, so we look over here. 3. 3 has a 1. So that means 3 is going to a 1. 3 cannot go to anything else. So we're going to look, is there any other 3s? And I'm only looking at the x values, right? For right now. There are no other 3s. So now let's look at 1. 1 goes with a 3. There's another 1 over here that goes with a 2. So which means it goes with 2 outputs, which means that this is not a function. Okay, look, same thing here. 1 goes to 3. And 1 goes to 5, which means it matches up with 2 different things, so it is not a function. 4 goes with 6, 5 goes with 6, 6 goes with 6. None of these repeat. The y repeats, but this one does not, which means this is a function. For the graphs, the easiest way to do this is the vertical line test, like we were doing a second ago. If I draw a vertical line through this point, does it hit any other point? It does not. What about this one? It does not. What about this one? It does. It hits 2 points, which means that this is not a function. Same thing with this. If I draw a vertical line, it looks like it hits more than 1, but it's really just hitting 1 point. There's no point where this doubles up, which means this is a function. So you can see here which ones are and which ones are not.